A Universal Machining Center, or UMC, is a highly versatile CNC computer, numerical control machine tool, designed to perform a wide range of machining operations in a single setup. What sets a UMC apart from other machining centers is its ability to handle complex, multi-axis tasks with precision, thanks to its advanced design. UMCs typically combine the capabilities of both vertical and horizontal machining centers, along with additional rotational axes. This combination allows the UMC to machine parts from virtually any angle, making it ideal for complex geometries and multi-face operations. To understand how a UMC operates, let's explore its primary axes of movement, including the additional rotational axes that give the machine its universal capabilities. In this example, this machine utilizes the B, C, X, Y, and Z axes. First, we have the X axis, which controls the horizontal left to right movement. This axis positions the workpiece or tool for precise horizontal machining operations. Next is the Y axis, responsible for the front to back movement. This axis, in conjunction with the X axis, allows the tool to reach various areas of the workpiece horizontally. The Z axis controls the vertical up and down movement of the spindle. This axis is crucial for setting the depth of cut during machining operations. Now, let's look at the B axis. This is the first of the rotational axes in a UMC and typically refers to the rotation of the workpiece around the Y axis. The B-axis allows the workpiece to be tilted, enabling machining on inclined surfaces. Finally, the C-axis manages the rotation around the Z-axis. This allows the workpiece to be rotated horizontally, enabling continuous 360-degree machining operations, perfect for cylindrical parts or complex contours. A universal machining center's strength lies in its ability to coordinate movements across these multiple axes. This coordination allows the UMC to perform intricate machining tasks in a single setup, reducing the need for multiple machines or manual repositioning of the workpiece. This capability is particularly beneficial for producing complex parts such as aerospace components, medical devices, and automotive parts, where precision and efficiency are critical. The UMC's multi-axis control ensures that every surface, angle, and contour can be machined with high accuracy. In addition to its multi-axis capabilities, UMCs are equipped with a variety of features designed to enhance productivity. These may include advanced tool changers that accommodate a wide range of tools, sophisticated control systems that allow for complex programming, and automation features like pallet changers that streamline the machining process.